Now, I'm sure that by now you probably already realized, right, that word problems are tricky, right? That's it goes without saying, right? Like you need to kind of you're gonna get better at it the more you practice. That's just bottom line. You can't just roll in and hope for the best. You know what I mean? Like when I assign questions, I don't assign a whole lot of questions. I don't tell you like do 10 questions, right? In fact, this worksheet only had 2 questions, but if you did them and you did them properly, it probably took you anywhere between, half an hour to 45 minutes, maybe even an hour, right? So it's a bit deceiving. So when you do these, please, or when I assign them for you to do them before I do them, I really want you to give it a try before you see it being solved, okay? And worst case scenario, you get it all wrong. You learn from those mistakes, right? And it's that attitude of, keep trying. I'm not going to give up. I'm gonna at some point at least improve, if not master, right? And so there we go. Okay, so let's start reading. I find it very important to read it carefully, underline things, and maybe even read it 2, 3 times before you start making and coming to conclusions or starting something, right? A lot of times we just want to dive right in and it's like, wait a minute, does this make sense, right? Even when you come up with your inequalities, go back. Does it make sense? Okay. All right, so here it is. Alyssa owns a small business selling pizzas. She knows that the most popular toppings are cheese and pepperoni. Right there, you probably are realizing, right, that cheese and pepperoni are going to be my 2 variables. I hope you see that, right? According to the feedback from her customers, she knows that a good pizza has to have at least that. Those are key words, right? Maximum has that much, up to, no more than, at least, right? At least 2 times as much cheese compared to pepperoni. Now that is somewhat new. I know that we haven't done one of these the twice as many or 3 times as many or whatever. But that's why I'm going to go over this with you. On average, a pizza has no more. A pizza has no more than 750 grams of cheese and 750 grams of pepperoni. And there are the highlighted portions, and let's try to see what we can make out of that. Okay, so we're going to try to graph this scenario because it's only through graphing where we can actually get our corner points, and it's going to be one of the corner points that is going to ultimately be the ultimate solution. Okay, so let x be something and let y be something else. I'm pretty sure you would all agree that this would be cheese and this would be pepperoni. So if you want to do that, sure. Okay. And then put the units after. Like what are we, is it number of, or is it, what are we talking about here? And I'm pretty sure you realize that it's grams after a while, right? That's what we're talking about. So in grams, because it's important to know what are the units in, because if it's number of cheese blocks or whatever, then we're talking about discrete data. Because it's grams, now it's a continuous, right? It's continuous data all of a sudden. So we state our implicit constraint or restriction. It's the same thing. We make a note that this is continuous, right? And that's all I have right now. I've done the first part. Let's come up with our inequalities. At least you need at least 2 times as much cheese compared to pepperoni. So how would you write this out? there is something about cheese and pepperoni that there's a relationship between the two. Okay, so if X is cheese, okay, and Y is pepperoni, okay, you need at least 2 times as much cheese compared to pepperoni. So where would you put the 2 in front of? That's always the tricky part. And you would want to put it in front of pepperoni, and you would want to say that X, right, cheese has to be greater than or equal to twice as much pepperoni. Does that make sense? That is confusing sometimes. It is confusing because you're like, well, isn't it saying 2 times as much cheese? Yes, but that's why you have to put it in front of the pepperoni, because now you're saying that, let's say you have 100 grams of pepperoni, right? You put 100 grams on the pizza. That means that X would have to be 2 times 100, right? It would have to be greater than or equal to 200, if you think about it that way, right? So this is the only way. So you say at least 2 times the cheese, right? Compared to pepperoni, that is. Okay, so that's our first inequality. Then we have another one, no more than 750 grams of cheese. This is very specific to cheese, okay? So X has to be no more, so that has to be less than or equal to 750 grams of cheese, okay? Sorry about the print, the printer isn't working properly. And pepperoni can be no more than 250 grams. No more than 250 grams of pepperoni. So you have 3 inequalities there, and that's all we have. Now, if this question had said that, a pizza can weigh, the maximum weight of toppings has to be less than, 1,500 grams or something, then it's a combination. That would be 750x plus 250y has to be less than or equal to 1,500 grams, right? But it's not saying any of that. It's just specifically stating a restriction for x and a restriction for y. That's all it's doing there. Okay, so let's work with this. We're not going to have a whole lot of room here to graph if I use this up, right? So I'm going to make my graph over here on the right. So I'm just going to label this 1, 2, 3 like that. Okay, and the first one, x is greater than or equal to 2y. I want y on its own, right? I want y isolated. That's how we know it. So what I'm going to do is I'm going to divide both sides by 2. And so that's really 1/2 x is greater than or equal to y. And here you have to follow me what I'm doing here. I'm gonna just flip this whole thing so that I have y on the left here, y, okay? And it's still gonna be pointing towards y, right? 1/2. No sign change, nothing. But this way, it is the way we want it to look, okay? Here you say that it's gonna be a solid line, and below is true, so we shade above. And what is my y-intercept here? Both x-intercepts and y-intercepts are 0, 0, okay? So this is one of the cases where we're going to use our slope to help us graph. Okay, so let's leave it like that for now. For the second one, that one right there is a vertical line. And I know it's going through 750, 0. Okay, it's going to be solid. And to the left is true. So I'm going to shade right. And I'm going to do talk about equation or inequality 3. It's a horizontal line, right? Goes through. And I'm going to because and there it is. Now I'm going to graph it. And I'm going to put cheese in grams down here. And put down pepperoni. I think my pepperoni has 3 P's. It's a different kind of pepperoni. There you go. Pepperoni and cheese. And I look at my x-intercept. I need to go all the way to 750, and my y-intercept is 250. So I think I'm going to go all the way to 800 or so along the x-axis, and probably yes. That's what I'm going to show you how to deal with a question like that. I will show you how to do that. Because one thing we know for sure, if you look at that, what's the y-intercept? It's 0, right? That I can make a note of. The y-intercept is 0, 0, right? You know you're going to go through the origin right here, guaranteed, okay? So just bear with me for a bit, and then I'll get that resolved, okay? Good question though, right? We notice that there is no x and y-intercept here, but we do know that the y-intercept is 0, 0, guaranteed. So we're going to start here, and then we're going to have to see where we go. So I'm going to go all the way to 800 here. So I think I have to go by a scale of 200 for that to work. So 200, 400, 600, 800, and I have more than enough space here. So 400, 800, right? And here I can space it out a bit more. So 100, 200, 300, 400, there it is. So no need to use the same scale, right, as long as you're consistent. So let's do our vertical and horizontal first. Vertical, we have 750. This is 600. This will be 700. So 750 is between those two. And make sure you don't go into the negatives, okay? You're just going to go try to make it parallel to the y-axis and go straight up. That's x is less than or equal to 750. Then you do your horizontal, that's 250, which is right here. And go across like that. And we will do the shading in just a little bit. Now, how would I do the other one? This one right here, the first one that I'm trying to graph. This is the trick, okay? The slope is 1 over 2. Got it? Tell me if you would follow. If I said that the slope is also 100 over 200, would that make sense? 100 over 200 is reduced 1 over 2, right? And why am I using hundreds? Because my scale is in the hundreds here. So it's easier. So that means that if I rise 100, I need to run how much? 200 right there. Right? You rise 100, you run 200 because your slope is 1 over 2. That's a rise of 1, a run of 2, which is the same thing as a rise of 100. I have a different scale here for both axes, so you got to watch out, right? 100, 200. So why don't we just label that one? Right? It's not going to be a corner point necessarily, but we're going to label that because now that I have the 0, 0 and the 100, 200, I can just use that as a reference and draw my line. And just draw it, make it go across like that. And this is y is less than 1/2 x. There's that. Now let's shade. We're supposed to shade above here, above the diagonal. So we do that. So everything above is false, right? Because we're using reverse shading. Then we're going to the second one, which is the vertical. We're shading to the right. So everything to the right is gone. There you go. And then this one, the last one, it's solid. We shade above as well. So that means that if we follow this, it eliminates that little triangle that was here, right? Because everything above this horizontal line is gone. So this is our solution region right there. Solution polygon, same thing. Notice that normally I asked you to state the corner points. How about we just label them 0, 0? Let's find these corner points here. This one right here is 750, 0. What's this one right here? It's the junction between a vertical and a horizontal, right? So this would be 750, 250. So I read this one, I read this one, I read that one. The only one you have to find here is using your calculator is this one right here. What is it? Oh, you're estimating? It's 250 for sure, right? And according to my notes here, it's 500. So this would be 500, 250. Probably not a good idea to label it inside, maybe outside would have been better, but it is what it is. So we've got our corner points labeled, and there they are. Don't think 100, 200 is a corner point. That was just a reference. I honestly don't know how to put that in your notes right now without making a big mess out of this. To remember, if it's one that has a 0 y-intercept, to just use the slope, right? Start at the origin and then go rise, run, rise, run. You could do that forever, really, but you only need one. Okay, so let me see. Back home, you might still need a bit more time here. Okay, B, if cheese costs 65 cents per 100 grams, right, and pepperoni costs 85 cents per 100 grams, determine the objective function. Okay, so there's a couple of issues here. It's per 100 grams. Everything we have here is per gram, right? Per gram, per gram. So we're going to figure out the cost per gram. So 0.65 cents divided by 100 grams, that would be 0.0065 per gram, right? And if you take the 85 cents here, divide that by 100 grams, you get 0.0085. Just do not round, okay, per gram. So now you know the price of each of them per gram. Where are we going with this? Well, we're supposed to come up with an objective function. And it's...
Sorry for the interruption, everyone. We are going to have a quick staff meeting at 3:30 over Microsoft Teams. So staff, I will be sending you a link shortly. Check your email. We're going to have a short staff meeting ready to go at 3:30 over Teams. Thank you.
Okay. The objective function here is now we're talking about cost. So the one that will give us the total cost to possibly determine the total cost is 0.0065x, right? Because you're paying this much. It costs you this much for every gram of cheese. And it's going to cost you this much for every gram of pepperoni. That is your objective function right there. And it's not an inequality. It will never be graphed. It's just an equation. If you forgot to divide by 100, your total cost would just be a lot higher later on when you do the math, right? So you don't want that, okay? C, determine the combination that would minimize. Here it is. That is the word. That's where optimization comes in. You need to, right? Optimize. Find the best solution, right? So we will state our corner points here on the side. So 0, 0, 500, 250. How did we find that? We actually, I used the calculator for that. You didn't have to. You can probably just plug it in, but I would suggest you do that. 750, 250, and then 750, 0. We've got 4 corner points, and we plug that into our cost analysis, okay? So the cost of making 0 and 0 would be 0, of course, okay? The cost for using 500 grams and 250 grams would be, you just plug in the X and the Y. The cost here would be this. The cost of this one would be, and this would just be 0 here, right? But you essentially just write it out like that and make sure you plug in X and Y every time here. Okay, and you run it through. We'll talk about the 0, 0 in a bit. And so the first one here gets you 488. The next one gets you 538. And the last option here gets you $7. No, wait. I didn't do them in the same order in my notes. Hold on, guys. 500 and 250 is 538. This is 538. $538, and this is 488. 750, 250 is actually $7. Never mind. and 500, and this one 750 0 is 488. I was mixing them up there. Now, which option would minimize the cost? You would say, well, making nothing, right? Making using 0 and 0. This one is in this case not applicable, right? Because as a business you want to make money. So not that's just not an option. You kind of just omit that, right? So you have to pick one of these three here. And the answer would be this combination, right? Using 750 and 0 would be the best option right here with minimized cost. Okay, using 750 grams of cheese and 0 grams of pepperoni would minimize the cost. That's the combination that will minimize, will give you the lowest cost possible. And you still have, you're not violating the requirement of having at least twice as much cheese compared to pepperoni, right? You have a lot more than that. And all the other requirements are also fulfilled there. So there you have that one. And we'll do the second one. Okay, just so you know, rating this question, this one is probably one of the harder ones. Okay, so if you were a bit like, whoa, right? There's a lot of things like dividing here by 100. That was an added layer. Okay, will something like this be on a test where there's so many hiccups that you could possibly have? Probably not, right? But on an AC, I could do that, but not on a test. So you don't have to worry about it too much, but you still got to have the at least twice as much of one compared to the other. You should, that one you have to be comfortable with. Okay, number 2. You can work a total of no more than 45 hours each week at your 2 jobs. Otherwise, you would just collapse because you're working too much. Okay. One pumping gas pays $12.50 per hour, and your sales job at an outbound call center is $14.25 per hour. You need to earn at least $345 to pay your bills. That there's a restriction there. The outbound call center allows you to work less than 20 hours per week. Okay. Graph the scenario, include all steps. So define your variables, come up with inequalities, constraints, all of that needs to happen here. Okay. So you notice that there are 2 restrictions here, and we're gonna go through that and see what we get. Okay. No more than 45 hours. You're allowed to work. Oh, sorry, there are 3 restrictions. What am I saying? 3 right here. And so we're going to come up with that. So I will use up my space up here because there's some space up there. X is hours worked. What are we pumping gas? Y would be hours worked at outbound call center. Okay. X and Y is greater than or equal to 0. This is continuous because we're talking hours, right? What are my restrictions? Well, the combined hours that you're working in each job has to be no more than 45 hours, so that's the one. Okay. I will do them side by side here this time. The other one is you need to earn at least $345 to pay your bills. So there's a restriction on money. So you got to go look up how much you're making so that those coefficients are in front of X and Y, right? So it's 1250 pumping gas for every hour pumping gas and 1425 for every hour at the outbound call center, and that has to be at least, right? This amount has to be at least 345 to make ends meet. Okay. And then there's one more. The outbound call center allows you to work less than 20 hours per week. So that's just talking about Y, right? The hours worked at the call center. That has to be less than 20. This is the one time I was able to sneak in a just less than, right? You can't do a less than or equal to, it's just less than. So this takes care of that. The 345 here, we needed to have the dollar amounts as our coefficients. The 45 is just talking about hours. What these represent hours, so that's the 45. So let's come up with our intercepts. And here we're going to actually calculate that. X and Y intercept would be 1250. X is equal to 345. Divide both sides by 1250. X is equal to 27.6. Just 2760 right there. The y-intercept would be 1425 is equal to 345. That's y. 1425, 1425. Y is equal to 2421. And so these are my intercepts. I forgot to rewrite the other one because I'm rushing. Y is less than or equal to negative x plus 45, solid above. This one ends up being 1425y greater than or equal to negative 12.5x plus 345. Divide everything by 14.25. And you get y is greater than or equal to. I'll just leave it like that because otherwise it gets too, like, you don't want to round. Plus 24.21. I think it's a finite decimal, that's why I put that down. This should be solid above, right? No, solid below, sorry. Because above is true, we will shade below. This is a horizontal line, and it goes through 0, 20. It's dashed, and below is true, so you shade above. And let's go ahead and graph this now. Pumping gas in hours, and this is call center in hours. I look at, if I go to 50s everywhere, I should be fine. So 10, 20, 30, 40, 50. I'm just going to label every other one. 10, 20, 30, 40, 50, 60. 45 would be here. 45 is there. Well, I didn't label, did I label the other one? The lines on the other graph? I'm not sure if I did. And then this other one is 27.6 and it's 24. 25 is right here, so 24 is right about there. There. And let me label this x plus y. So let's go 45. This one I'm going to label over here 12.5x plus 14.25 y is greater than or equal to 345. Don't let the ugly numbers throw you off, okay? Like the decimals and whatnot. And then the other one is at 20 is right here and it's dashed. So you can be guaranteed if that's the case, right? There'll be extra marks associated with you catching that. Let's shade. Solid above, we're shading above for this line. And then for this one, we're shading below. And this one we're shading above. So we've got a parallelogram, almost. All right, so this is your solution here. I will label the points here. This is 27.60 here. This one, I will tell you what it is. It is 2520. And this one here is 4.820. And again, you would have to use your calculator for those. Okay. Write the objective function to calculate the total income. How would you do that one? I'm going to call this capital I. The equation that would tell you the total income is very similar to this one here. Watch. It's very similar to this, but this is not an inequality. So you would just simply have to say 1250x plus 1425y, and this is it. That's your objective function. What combination would result in the maximum income? Let's write them down here. I will try to do it. And because it's continuous data, it doesn't matter if it's a decimal corner point. Okay. So write them down like this, run it through our I equation, and see which one of these combos will give us the most income. This would be 1250 times 4.8, and the rest is 0, right? We figured that out. 1250, 25 plus 1425 times 20 hours. This one is 1250, just working 45 at the gas station. This one is 1250 27.6, like that. And let's see if I can manage to not mix them up. You get 345 for this one. You get 596, sorry, 597.50 for this one. You get 562.50 for this one. And you get, oh wait, yes, you just can't see it. It's there. You see it right there? Yeah, there. I'm just joking. I made a mistake. 27.6. This is 345 as well. So which one of these gives you the maximum income? This one. Okay. Maximum income by working 25 hours at gas station and 20 hours at call center. And I'm going to say something here. You don't have to worry about a dashed line like this. You know how technically the point on that dashed line is not part of the solution? I'm going to go up once. Remember that if it's on a dashed line, it's not part of the solution. You will never have to worry about that in a word problem. I won't do that to you, okay? Because it just complicates things. And so that's not the point. The point is just to find the maximum out of the corner points, and you get that. All right, that's that. Hold on, before you pack, before you turn off your brain, okay? Which I don't blame you. I would want to turn it off as well. I want you to find this handout right here. Try to find this handout. It's called Optimization Review. I want you to do 1 to 6. Okay? So I'm going to tell you here, homework, work on optimization review 1 to 6. And you basically do everything we've been doing for every question. Okay? Graphing, coming up with the inequalities, all that fun stuff. You call that fun? I wouldn't say that it's fun, but you got to do it, okay? Anyways, if you're home, hang up. Have a good one. See you tomorrow. Yeah, see you. And I'll probably not see you in person until next year. So, Merry Christmas, Happy New Year, Happy Holidays. Take care, guys. Stay safe, okay? And try to stay positive. I know it's hard, especially at your age. I think it's harder than for us, honestly, because you kind of don't see, you can't see ahead sometimes. So it's gonna get better. Just focus on graduating, okay? That honestly, like make that your goal. I'm gonna graduate next year, okay? And then we'll see what happens next.
5 foot 12 is 6 feet. There is no second digit. Five. If it's 5'6", it's 5'6" Oh, so if I say I'm 5'7", then I'm 5'7" inches tall. I'm surprised you didn't know that.
Didn't you do that in IPR?
Yeah, we did.
Yeah, you should have. That's fair.
Measurements coming up next year.
That's right, it's waiting. I'm waiting for you. Okay, have a good one, guys. Stay safe. See ya. Have a good one. Yeah, right here. See you guys. Oh, you couldn't go the handouts. If you didn't those who forgot. Do you have the measurement already, right? Have a good one, guys. Yeah, see you. See you guys. See you. Oh, sorry, that is not for you. You just took this one, yeah. This is you put these in the front. Bye. Yeah, see you. Have a good one, okay?
This is just a reminder to all staff that there will be a Teams meeting in the next 3 to 5 minutes or so. Thank you.